So in today's lecture, we will discuss about trigonometric derivatives. We have 6 trigonometric functions: the sine function, cosine function, tangent, secant, cosecant, and cotangent function. Now, the derivative of the sine function is the cosine function, and derivative of the cosine function is the negative sine function. So what we will do, we'll try out derivative of the sine function and derivative of the tangent function by using the first principle. That means we'll use the limit definition of derivative to obtain the derivative of sine x and tangent of x. So let us begin. So first we will consider derivative of sine x. So here our function is sine of x. So that means we have limit h approaching 0. So we need f of x plus h. So this will be sine of x plus h minus f of x, which is simply sine of x, all divided by h. Now we will use the formula that sine of a minus sine of b, so that's equals to 2 times cosine of a plus b divided by 2 multiplied to sine a minus b divided by 2. So let's apply this particular formula to the numerator. So this will give us limit h approaching 0. We have 2 times cosine of a plus b over 2. So here a is x plus h and b is x. So we have x plus h plus x divided by 2 multiplied to sine x plus h minus x divided by 2 whole divided by h. So we'll simply multiply it with 1 over h, means the same thing. So this will be equals to, so we have limit h approaching 0 cosine of, so we have 2x plus h over 2, x and x gets cancelled, h over 2 multiplied to 2 over h. Right. So this will be equals to limit h approaching 0 cosine of, so we have 2x plus h over 2, or simply x plus h over 2 times sine h over 2 whole divided by, so we have 2 multiplied to 2 over h, so this is simply whole thing divided by h over 2. That means the same thing. Now when we apply the limit to these two functions, so we have two functions here, cosine of x plus h over 2, so this will become cosine of x plus 0 over 2, and then we have sine of h over 2 divided by h over 2, so that by definition is 1. We're using the definition here, limit h approaching 0, sine h over h is equals to 1. So this leaves us with cosine of x. So that means derivative with respect to x of the function sine of x, this gives us cosine of x. So we can use the same technique, and from the first principle we can obtain the derivative of the cosine function. We have derivative of the cosine function, and that will give us the sine function with a negative sign. So let's try out another derivative. Number 2. So we want to find out the derivative of the tangent function. Now we know that the tangent function is the ratio of the sine function and the cosine function. So we will take the derivative of sine x over cosine of x, which is the same as taking the derivative of tangent of x. For this we will need to use the quotient rule. So for quotient rule we will start with the denominator. So we have cosine of x. So we take the denominator and then square it. Then in the numerator we have cosine of x. Then this will be multiplied to the derivative of the numerator minus, in the quotient rule we use the minus. Then we have the numerator multiplied to derivative of the denominator, which will be equals to cosine of x times, just now we have performed the derivative of sine of x, and that is cosine of x minus sine of x multiplied to derivative of the cosine function, and that is negative sine of x. So this will be divided by cosine squared x. which is equals to, so we have cosine squared x, so this negative and this negative becomes positive, so we have some cosine squared x plus sine squared x divided by cosine squared x. So cosine squared x plus sine squared x, so that is 1 by definition, so we have 1 over cosine squared x, and we know that 1 over cosine of x is the secant function, so 1 over cosine squared x will give us the secant squared x. So this is the derivative of the tangent function, so this is secant squared x, which is the final value. Let's move on to the next problem. Problem number 3. So here we are provided with the function x raised to the power of 4 times cosine of x. We need to find out the derivative of the given function. So f prime of x is equals to d dx of x raised to the power of 4 times cosine of x. So here we will need to use the product rule because we have the product of two functions, x raised to the power of 4, which is function 1, and cosine of x, which is function 2. So we take the first function and multiply it to the derivative of the second function. Then we have the second function multiplied to the derivative of the first function, which is equals to x raised to the power of 4. So derivative of the cosine function is negative sine x. So we have to remember that there is a negative sign involved here. This is extremely important. Then we have cosine of x multiplied to derivative of x raised to the power of 4. So we can use the power rule. So this will be simply 4x raised to the power of 4 minus 1. So this will be cubed. So that means we can take x cubed as the common factor and we'll write the second term as the first term. So this will give us 4 times cosine of x minus, so we have x sine x. So this is the derivative of a given function. Let's move on to the next problem. So we want to find out the value of the secant function using the quotient rule. First, we have to remind ourselves that the secant function is simply the reciprocal of the cosine function. Now we take the derivative on both sides. We have d dx of secant of x, which is equals to d dx of 1 over cosine x. So we have to apply the quotient rule. So we'll start with the denominator. We have cosine squared x. Then in the numerator, we can start with the denominator. So cosine of x multiplied to derivative with respect to x of 1 minus 1 times derivative with respect to x of the cosine function. So this is equals to cosine of x. So derivative of 1, so that will be 0 minus 1 times derivative of the cosine function is negative sine x whole divided by cosine squared x. So we get sine x divided by cosine squared x. So we can write the cosine squared x function as cosine of x times 1 over cosine of x, means the same thing. So sine x over cosine of x, this ratio is simply the tangent function. So we have tangent of x, and 1 over cosine of x is the secant function. So this means that the derivative of the secant function is the product of the secant function and the tangent function. Let's move on to the final problem. So we have the function g of x, which is equals to cosecant of x divided by square root of x. We need to determine the derivative of this particular function. So let us begin. So clearly we see here that this is a quotient of two functions. That means we need to apply the quotient rule. So g prime of x, apply the quotient rule. So we'll start with the denominator. So we'll take square root of x and then square it. Then in the denominator we have square root of x multiplied to derivative with respect to x of the cosecant function minus cosecant of x times derivative with respect to x of the denominator, which is square root of x. So that is simply x raised to the power of 1/2. So this will give us square root of x. So we have derivative of the cosecant function. So this gives us negative cosecant x times cotangent of x minus cosecant of x. And we use the power rule to obtain the derivative of x raised to the power of 1/2. So that will be 1/2 multiplied to x raised to the power of 1/2 minus 1 divided by, so square root of x whole squared, so that is x. So this gives us negative square root of x times cosecant of x times cotangent of x minus 1 over 2 times, so we have x raised to the power of half minus 1, so half minus 1, so this is equals to x raised to the power of negative half, or simply 1 over x raised to the power of half, which is simply 1 over square root of x. Now that means we have 1 over 2 times square root of x times cosecant of x, whole thing divided by x. Now what we'll do, we'll multiply it, the numerator and the denominator, with negative 2 times square root of x, and we do that to the denominator as well. So our first term will become, so we have 2, negative 2 times this negative will become positive 2, square root of x times square root of x will become x. So we have cosecant of x times cotangent of x, and this will become plus cosecant of x whole divided by, so we have negative 2x times square root of x. So this is the derivative of our function g of x.